Hi class, I would like to show you Phosphagen system is related to mitochondria respiration system. So it will be really good lecture, it's important. Right? So first I want to draw is a one muscle fiber. Oops. Yeah, so how about like this? So this is the membrane of muscle fiber, membrane of a muscle fiber, and it look like the T, right? Letter T. So it look like T. So this is the T tubule, T tubule. So close the T tubule, there is sarcoplasmic reticulum, sarcoplasmic reticulum. It look like this. It look like this. Sarcoplasma reticulum. It releases calcium ion. So inside there are lots of calcium ion, lots of calcium ion. When we need muscle contraction, sarcoplasmic release calcium ion. Oh, how about did you remember? How about like this? This is a membrane, is right? Membrane of muscle fiber or sarcolemma. Sarcolemma has like this kind of thing, right? Well, it's it's a microline. Okay, so this is axon and axon terminal, and look like this. Can you guess what is this? Neuromuscular junction. Doesn't make sense. So it make action potential if we sending signal to the muscle fiber. So action potential is propagate through the T tubule, and this change of like action potential of a potential, it activates sarcoplasma reticulum, and sarcoplasma reticulum release calcium ion to the where sarcomere is right, actin and myosin. You already learned human physiology about sarcomere, sliding filament theory, is right. So it's release calcium ion, right, in the actin myosin like a muscle fiber. So how about I can write down it here. So this is like uh, actin, and this is myosin. This is actin, and this is myosin. Yeah. If you want more, like a Z line is here, right? I think you remember, right? Right. So actin and myosin. So actin and myosin look like this. Myosin head look like this. Doesn't make sense. Doesn't make sense. Yeah. So and another one. This is the another side of membrane, right? Yeah. So maybe T tubule is like this. And when is neuron sending signal to our new membrane, right? So when we have action potential, right? If we make action potential, our muscle membrane, so actually inside is negatively charged, outside is positively charged at rest, is right. But after depolarization, is outside is negative and inside more positive, right? And return, right? Inside negative again, outside positive. This is action potential. How can you do? That case actually inside potassium go outside, outside sodium move in, is right. But after change, after repolarization, outside potassium should move in, and inside sodium should move out, is right. So we need to make resting potential again. We need, I think you guys remember, is right, sodium potassium pump. Class, did you remember sodium potassium pump? Did you remember sarcoplasmic reticulum release calcium? Did you remember actin and myosin or sarcomere, right? Has a myosin head. So we learned just ATP hydrolysis, right, to give energy. So actually ATP's role in the cell is to give energy to the myosin head. And there are another one too, but how about simply myosin head, right? And we need energy to pump back calcium ion into the sarcoplasmic reticulum, and to should energize this sodium potassium pump to make re resting membrane potential. Yeah, is right. Yes. How about like this? So to energize this myosin head, we must break down ATP. We must break down ATP and break down ATP. So ATP it should be become ADP. Do you agree? Do you agree? Which enzyme we need? ATPase. ATPase, right? So this breakdown ATP release energy. This released energy is energized this myosin head. Bam, bam, bam. Right. So it makes sense, right? And how about this ADP? We can resynthesize ATP. How about class? Did you remember? Did you remember? How about here? Another ATP is here to energize myosin head. Bam, bam, bam. Is right? And become ADP. Is right? So this case is easily if we have creatine phosphate is here. Is right? Creatine phosphate and creatine phosphate can become creatine and give this phosphate group to the ADP and we can resynthesize ATP. Makes sense? And this ATP can energize this myosin head and become ADP. And creatine phosphate give inorganic phosphate to the ADP and become creatine and ADP become ATP. Is it right? Which enzyme? Which enzyme? Creatine kinases. Is it right? Is it right? And however, sometime after creatine phosphate, did you remember using 2 ADP in make 1 ATP, make 1 AMP? Did you remember? Is it right? So if we have another ADP, yeah. So this ADP give inorganic phosphate to this ADP, and one of the ADP become ATP. This case maybe this one, right? And this one is which one? ADP give inorganic phosphate to the this ADP. So this ADP become ATP. How about this one? Which one? AMP. Makes sense? The Phosphagen system. Is it right? Is it right? Yeah. So how about this AMP can become ADP using ATP and another ATP become ADP. Is it right? Oh, I think this is creatine kinase reaction, Dr. Gon, right? And this is the, what is this? This is adenylate kinase reaction. Adenylate kinase reaction. Is it make sense? Is it make sense? Yeah. So how about this ADP? Should it be become ATP? Is right? Is right? So this is important. This time is important. So at rest, at rest. So how about here? This creatine phosphate can give creatine, inorganic phosphate to the this ADP. So it can be ATP and become creatine. So class is right now is important. Is important. So if you have mitochondria is here, and I think you watch my micro lecture of the Phosphagen is not for high exercise intensity. That lecture is right. So please watch here. So if you have mitochondria is here, mitochondria is here. You know, mitochondria has like this kind of folding. I think you remember is right. And mitochondria is double membrane. Is right. And you already watch my micro lecture of the what is this? The Phosphagen system is not for high intense exercise. See, there are creatine kinases on the mitochondrial membrane, especially inner membrane. The name is mitochondria creatine kinases. So MTCK, right? MTCK is here. This is the shorter. It's a shorter. This creatine phosphate give phosphate to the ADP and become creatine. If this creatine is close to mitochondria as well as if there are mitochondria kinases here, so this creatine get an inorganic phosphate from through this enzyme and make a creatine phosphate. It makes sense. It makes sense. How? Because mitochondria can make ATP. So mitochondria synthesize ATP, is right? ATP and break down that ATP, so become ADP and inorganic phosphate. Yeah. So creatine get this inorganic phosphate through the mitochondria creatine kinases and resynthesize this creatine phosphate. Wow! I believe our kinesiology major student it believe like phosphagen or creatine. Creatine is for high exercise intensity. Usually sprinter, powerlifter, bodybuilder use this supplementation. Is right. And many supplement companies said creatine is good for high intense exercise. Is right. Did you remember I said creatine supplementation company said? Is right. It's not like a scientist said. Scientists maybe can say that, but for me, creatine is always winning. It makes sense. Is it right? Because of creatine, mitochondrial creatine kinases, we can resynthesize from the mitochondria. But many times we believe we have only creatine phosphate in our cytosol. Yes, it's correct, but the enzyme is in this case in the inner membrane of a mitochondria. We can get inorganic phosphate from the mitochondria. Wow, it's mean whenever you need creatine phosphate, right? We need resynthesizes, right? That case, if you are really endurance athlete or endurance trained people, right? You have a lot of benefit. It doesn't make sense. But many times, our steroid high is like creatine is for high exercise intensity, right? Is it right? But actually, we need always we need. It doesn't matter is exercise intensity. You can get a benefit if we have more mitochondria, size and number. Does it make sense? Oh, so we should be trained even endurance, even some high power, like high high, no, how can I say? It's powerful athlete. They need mitochondria also. It means they should exercise endurance also. Makes sense? And I want to keep going, right? So next one, how about class? Please watch here. During exercise, oh, how can we have this kind of reaction? Actually, our neuron sending signal and activate this membrane, neuromuscular junction, and neuromuscular junction is make action potential, and finally activate this sarcoplasmal reticulum. So sarcoplasmal reticulum releases calcium ion, is right? Is right? You will learn sliding filament theory in detail after exam 1, but at this time this is enough. Right? So calcium release and there are muscle contraction, but after muscle contraction, if there are no more muscle contraction, this calcium should go back to the sarcoplasmal reticulum. This calcium should go back to the sarcoplasmal reticulum. Right? But put that calcium ion to the sarcoplasmal reticulum, we need calcium pump. Calcium pump here, right? Wow, we need a pump, right? This pump can put calcium ion into the sarcoplasmal reticulum. But the name is pump. How about in real world? Pump need electricity, power is right. It's the same. To pump back to calcium, we must energize this pump. How? ATP, right? So break down ATP and become ADP, is right? So we energize. After energize, class, did you remember our body won't have the same concentration, constant concentration of ATP. So whenever use, we must resynthesize, is right? So there are creatine phosphate there. Actually, sarcoplasmal reticulum is very close to mitochondria. So here, so ADP, it should be resynthesized ATP to do this one. We can using creatine phosphate, give inorganic phosphate to the ADP, and so this ADP become ATP, and this creatine phosphate become creatine. But how about class here? If you have developed mitochondria. If we have developed mitochondria, more mitochondria and big mitochondria, right, compared to your muscle fiber, because you are trained people, that case, mitochondria, creatine kinase is here, the enzyme, right? So this creatine can get inorganic phosphate through the mitochondria and become creatine phosphate. Is it right? Yeah. So we can resynthesize it easily. We do not use just creatine phosphate in cytosol, right? If we have more mitochondria, you have more advantage. Doesn't make sense? Doesn't make sense. Wow. Creatine, creatine, I believe this is important during high exercise intensity, but when we need this pump during rest, during recovery, is right? Because during contraction we need calcium, but if you stop exercise, this calcium should move back to the sarcoplasmic reticulum, is right? At that time, still we need creatine phosphate. Wow, it's right now you change your mind, is right? Oh, I think why I think the creatine phosphate is so important, but actually it is important for any exercise intensity. Yeah. Does it make sense? Doesn't make sense. Another one, another one. So during sending signal to our sarcoplasmic reticulum release more calcium, but how about if you stop exercise, your brain stop sending signal to your muscle fiber? It means our muscle fiber, especially membrane, right? It should be repolarized, is right? We need just resting situation. But how about after exercise? After exercise, right? So potassium is out and sodium is in, is right? But we should change at resting level. That case, sodium should be out, potassium should be in. Does it make sense? Which one do? Sodium, potassium pump do. So sodium potassium pump, right? Sodium potassium pump, right? This is pump. It should be energized. How can we energize this pump? Using ATP and energize this pump and become ADP. And this ADP should become ATP, right? Because our body is a body want constant concentration of ATP. So whenever used, we really want to resynthesize ATP. See, we should resynthesize. Which one do? This case, creatine phosphate again. Creatine phosphate give inorganic phosphate to the ADP and become creatine. Is it right? Is right now the problem is we must resynthesize creatine phosphate. If you have highly developed mitochondria, if you have more mitochondria, if you have more uh, bigger mitochondria, functioning well mitochondria, right? If we have, but actually, how can you increase this mitochondria and how to increase the size of mitochondria number, right? Like this, you need training. You need training. Is it right? So this is how exercise is important. Again, exercise is medicine, right? So this creatine should can get inorganic phosphate from the mitochondria again, right? That shuttle, and how about what is this? The enzyme name is same, MT creatine kinase, mitochondria creatine kinase. This one is get inorganic from mitochondria and resynthesize creatine phosphate from creatine and give this creatine phosphate to the cytosol. Wow. So many things, many things. Why we need ATP to to energize myosin head to muscle contraction. Why need ATP? Why we need ATP to be relaxed? When you relax, we should put the calcium ion into the sarcoplasmic reticulum. We need ATP. When we need another ATP, when we need ATP again, sodium potassium pump should be energized to get resting membrane potential, that concentration inside more potassium, outside more sodium, like that kind of concentration. Is right? This side. If you have very developed mitochondria, wow, mitochondria creatine kinases using creatine phosphate in out of the mitochondria to do all of that. Does it make sense? So this is why I said, wow, Phosphagen system is so important. right? The most important Phosphagen system is creatine kinase reaction. And it's important for at rest and during high exercise intensity, right? During high exercise intensity, we use this creatine phosphate more. Is it right? Is it right? But I want to say creatine phosphate, creatine kinase is important at rest. Anytime, anytime. Does it make sense? I think you understand, right? So, and another one, this mitochondria, how to resynthesize ATP. How about class? Did you remember? So right now you should know, right? You will learn, you will learn. This mitochondria should resynthesize ATP. Which one we need? Which one we need? Yes, how about here? So mitochondria need oxygen, is right, and release CO2 and make ATP, is right. So if you breathe in air and breathe out, we call ventilation. But this one is oxygen becomes CO2, is right. We call this is a gas exchange. We call respiration. Does it make sense? So this is why we need to call mitochondrial respiration. And how important this mitochondrial respiration system make lots of ATP, is right? And this ATP can be used all energy system, is right? But if you exercise high exercise intensity, that is a different situation. But still, creatine phosphate, creatine kinases, this case mitochondrial kinase, is important for at rest. So we cannot really say phosphagen is only for high exercise intensity. But usually I learn like that, right? So this is kind of like using both lecture about phosphagen system is not for high exercise intense exercise. Does it make sense? And I believe this is kind of big picture, help you understand is another aspect of phosphagen system. Thank you very much.